Hello, everybody. Today, my team and I are going to discuss the feasibility of improving catalytic converters in gas-powered vehicles. Our team includes Daniel, Sergio, Shri, and myself, Sean. Now, you may be wondering, what is a catalytic converter? Patented by Eugene Houdry in the 1950s, catalytic converters are emission control devices that use a catalyst to transform those harmful compounds that come from an engine's emissions into less harmful ones. They've been a staple part of automobiles since the 1970s, and according to the IPA, they convert over 90% of the compounds that come from the engine into less harmful substances. All that being said, the question becomes, is there a way to improve these catalytic converters? Our team believes that the answer is a resounding yes. The efficiency of this technology has room to improve, since gasoline cars still have a negative impact on the environment. The goal of our research is to find ways to enhance catalytic converter technology to a point where the driver's ecological footprint is significantly reduced. First and foremost, we have to examine whether the technology can improve the efficiency of catalytic converters. Looking at history, it's clear that catalytic converters have improved in efficiency and durability over time. The Universal Technical Institute describes the two primary kinds of catalytic converters: the two-way, which only has oxidation catalysts, and the three-way catalytic converter, which added a reduction catalyst alongside the parts that the two-way already had. This evolution over time is a perfect illustration as to why the catalytic converter can and will be changed in the future. But how exactly can we make these converters more efficient moving forward? Well, according to Dr. Neil Cantor, owner of Chemical Solutions, this can be done by placing the platinum catalyst atoms in a metal oxide, which makes the catalyst much more efficient in doing its job. How will we do this? Well, let me introduce you to incipient wetness impregnation. This method is used to prepare the catalyst at a relatively low cost with a limited amount of waste, meaning it certainly can be used when we're doing this study. By preparing the catalyst, we increase the size of the active metal particles, which ultimately increases the efficiency as well. While these changes have yet to be tested within the structure of a catalytic converter, the science and technology behind the changes does exist, meaning this study is in fact technically feasible.
Over the years, catalytic converters have evolved to last the lifespan of the car, which in average is around 15,000 miles, which is approximately 241,000 kilometers. However, the average lifespan of the catalytic converter hasn't increased. In fact, catalytic converters give out way before the car does and are expensive to replace. A non-functional catalytic converter has a significant negative impact on the environment, as in results increase harmful emissions from vehicles. Now let's discuss the solution to many scientists are leaning toward. This is placing a platinum atoms in metal dioxide. Dr. Neil Carter suggests that this solution can increase the efficiency of the catalytic converter, result in drastic reduction of harmful emissions. However, it is important to know that this idea is still in the experimental phase. According to the article, the term of the active vehicle exhaust catalytic sites. This is a very complicated task that involves a large number of experiments. The Department of Energy's Association Acceleration Laboratory at Stanford has been working on these experiments for years, but have their success has been limited due to a limited understanding of how noble metals catalyze. There have been some promising experiments, such as the work that Dr. Han Jun and his team, who achieved success in a single catalytic converter. However, even with these promising results, the transitions to implementing this to all catalytic converters remains a grand challenge. My team and I believe that adding platinum atoms to catalytic converters is operator feasible. It requires a substantial investments in terms of money, research, and times. However, if our company can overwhelm these challenges, this is potentially the solution and can benefit our company significantly, economically speaking, but also environmentally.
When considering the economic feasibility, there are a number of costs that need to be evaluated. There must be an initial capital investment which will be utilized in providing materials, technology, a suitable facility, and labor. When acquiring a suitable facility, other costs that need to be considered are the size, its location, and whether the facility is leased or purchased. For capital expenditures, this would include materials such as platinum, rhodium, palladium, etc. Additional compounds such as nitrogen, oxygen, unburned hydrocarbons, etc. Welding equipment, general tools such as wrenches, sockets, etc. Vehicles where our catalytic converters can be installed, car lifts, technology that will modify or build the catalytic converters, and safety equipment such as eye protection and gloves. Variable costs will include material and compound supply usage, energy consumption, equipment usage, and labor staffing. Energy costs would depend on how frequently the equipment is utilized and the local utility rates. If we incorporate renewable energy resources such as solar panels, we can reduce variable costs in the long term. Based on the frequency of the equipment usage, some equipment may have to be replaced over the course of the project. We can reduce this cost by minimizing the number of experiments and performing maintenance on the equipment. When considering the labor and staffing, the costs associated will be the wage rates and the number of personnel we require to complete this project. This will depend on the project scale and the length of the project. Project-related costs may include consultation fees for facility design, mechanics, chemistry, and compliance certification experts. These costs will be utilized to provide assistance in setting up the facility as efficiently as possible, provide extensive knowledge on the catalytic converter and what modifications can be done at the mechanical level, provide information on how the metals and compounds interact with each other inside the catalytic converter, offering suggestions on what materials can be used to improve the catalytic converter at a scientific level, and aid in ensuring the final product catalytic converters meet emission standards and comply with government regulations. Some fixed costs will include property taxes, facility rent, or mortgage payments, and insurance. Insurance will provide general liability protection for our personnel and equipment loss and property damage. Depending whether we decide to lease or buy the facility, payments will serve as a cost. The economic feasibility of improving the efficiency of catalytic converters should account for the capital expenditures, variable costs, project-related costs, and fixed costs. Being mindful of these costs, if we are attentive, carefully plan, and coordinate efficiently, we believe this project is feasible.
The environmental feasibility, the main part of the environmental feasibility would be the resource efficiency, which includes that the process used to create the enhanced catalytic converters achieved through the process of wetness impregnation can effectively reduce harmful emissions from cars and industrial processes. This process allows for precise deposition of precious metals on certain ceramics, and these precious metals need to be mined. Therefore, this would cause less environmental damage, as less precious metals need to be mined, as there would be reduced in demand. By using these improved converters, greenhouse gas emissions, particularly hydrocarbons like carbon dioxide, are significantly reduced, leading to a decrease in the negative effects of emissions on climate change and therefore global warming. Additionally, this method improves air quality, reduces pollution-related illnesses due to the decrease in volatile compounds in the air and pollutants, and also contributes to the preservation of the ozone layer. Overall, integrating wetness impregnation into the production of catalytic converters is environmentally friendly and an efficient way to reduce emissions and improve living conditions. Improving catalytic converters and reducing harmful emissions is crucial for mitigating environmental pollution. However, before implementing such modifications, it is important to consider the legal aspects. The best process for developing catalysts, called incipient wetness impregnation, is patented, and replicating it without authorization would infringe on the patent holder's rights. It's important to obtain permission from the patent holder to avoid legal disputes and potential damages to the company. Additionally, modified catalytic converters must comply with the emission and safety regulations, and testing must meet the required standards. Every single state has different emission and safety regulations. Therefore, to implement this, modified catalytic converters in the US would require for them to comply with the emission and safety regulations of every single state. Adhering to these regulations is not only a legal obligation, but also ensures public safety and environmental protection. Therefore, it is necessary to collaborate with legal attorneys to address patent rights, certification, and testing requirements to ensure a legally feasible development process.
So, overall, the goal for this study was to find whether improving upon the catalytic converter is possible. We found that the science and technology behind improving catalytic converters exists and could possibly be implemented. We also discovered that a good amount of testing and experimentation may be required to implement these changes on a larger scale, driving up the cost of production and the need for facilities. However, if we plan carefully, coordinate efficiently, and stay attentive, we believe that this project is economically feasible. To add on to that, catalytic converters are not only environmentally feasible, but beneficial to the environment in general, for the reasons we listed earlier. And legally, the study should be feasible as long as we comply with safety regulations when making these desired changes. Therefore, we decided that improving the efficiency of catalytic converters is feasible. Thank you for listening to our presentation.